For this presentation of Creo's computer-aided verification extension, I'm going to be using this little guy here. It's an alignment guide for a landing gear. And you'll see it's typical Creo part. I've got dimensioned features, I've got GTOLs called out. That's what we're going to inspect, so let's get at it. So when I say new instead of part or assembly, I'll say manufacturing CMM. So I'm going to actually create a new .asm. It's an assembly model, but this is going to be a manufacturing model, specifically a CMM. So I'm going to start with a template. So you can see I've got a plate laid out. I've got my Zeiss called out. But even though it's a .asm, you'll see I have an inspection ribbon with all of my various functions I need for measurements and construction, verifying. I can go look at my probes. You'll see here I've got a couple of default probes that come with the system. You have a single tip. You have a multi-tip. These are Creo solid models. You can also assign, in this case, this is an articulated probe, so I've got a roll and pitch. So these can be solids. You can take these, modify them. You can build your own, whatever you need to for tooling. All right, so I'm going to go ahead and assemble my part in. So there, again, there's no translation. There's no changing formats. I use normal Creo assembly techniques to go ahead and place this exactly where I want in my holding fixture. So let me space it over there. Go ahead and flip this thing around so I've got the right orientation. But again, it's nothing different. I'm just assembling a Creo model into a Creo assembly. All the same techniques are used, and now I'm ready to go. Now I've got a default coordinate system for my machines, kind of edge of the table or center of the table, something like that. I need to move my measurements locally, so let's go probe some points. I'm going to take just the single tip probe, and all I have to do is pick on, in this case, a surface, and it builds a construction point right where I pick and generates a probe. So you'll see here's the Demas file. It actually goes and does it. I'll just do that 3 times. Got X. This will do for Y. Let's do it again for Z. And so now as I do that, at any point, I can say, well, let's show my probing operation. There's my probing the 3 points. Let me slow that down a little bit. And you'll see I've got controls for offset distance, for retract, lots of things set there. Now that I've probed this face of these 3 faces, let's go ahead and reset XYZ 0. So if I say I want to connect them to things that I've probed, well, here are those datum points. Whenever I probe something, it constructs either a point or a surface on that feature. And that allows me to now say, okay, now my reference coordinate system is right on the edge of the fixture. So from there, let's go measure the part. So if I go in and say, let's measure a plane, all I have to do is pick on a planar surface on the part, and then I can have the system automatically build me a grid of points based on spacing and so forth. If I like that, play it. See, that looks good. Or I can change the order, change the number of points. You know, really just need 3 to get a plane, so it's sort of a default, but you can get whatever level of detail you need. Now let's go ahead and do the same thing. Let's do this back plane. This time, let me just manually pick points. So you'll see I can say, I want to probe here, 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 and here. So it can be very automatic. It can be very manual. Really up to you as the quality engineer. How do you want to move this around? What do we need to clear? We'll talk about collisions and so forth here in just a second. But that looks pretty good. So now I've got 2 planar measurements made. Now let's go ahead, let's do some cylinders. So let's say I want to probe the outside of this part. Well, all I have to do is pick that outer surface, put some points on it, either automatically or I can do it myself. And now I've got a good set of probes. So I can play it and watch it, but it's going to be a problem. Notice with this orientation, getting those probes, oops, I'm running into the part. So a couple of things I can do. I can turn on collision, and it will do collision checking as it plays. In this case, the fix is pretty easy. Let's just get out our articulated probe. Go ahead and roll it 90 degrees. Then play that same path. And that looks like that may work a little bit better. All right. So I can control it that way by simply picking the appropriate probe orientation that will allow me to do the task I need. Same sort of thing, let's probe this interior cylinder. Put some points on there, and so forth. Now this one, the probe's in the right orientation. It always remembers the last one. But look at that first move. So the actual probing is actually okay. It's moving around inside there, probing the ID, but entry-exit. As it starts, as it ends, we got a problem. It comes straight up to the clearance plane. So now let's actually add some motion. So let's say I want an entry path that starts, inch or so out. Same thing, I want an exit. Come out an inch. So before and after you do this, let's move around. So again, that low-level sort of control. Say, yep, do this, but in this one, I need to get a little more control, a little extra detail. Let's go do that. So that looks good. Let's do one more feature, maybe this inner bore here. Let's say I want to probe that surface. So I'll show one other thing. So if I automatically put my grid of points on there, so forth, now I just have a single layer, but obviously got to change to the vertical tip. But my default values aren't quite what I need. Notice what happens when I play this. My retract value, my measurement value, they're all too big. Well, those are parameters. They're very easily set as defaults, but in this case, I need to make a change. So here you can see feed rates, acceleration rates, and now what I'm going to do is change some things like pull-out distance. So how far do I pull out once I've probed? So I'm going to set those to much smaller values. That'll allow me to actually go into this bore and move toward the wall to probe and move off of the wall, but in this case, very tiny amounts, because that's what I have room for. Again, I can rerun that collision checking if I'm worried about it. As it is, nice little star pattern there. That looks pretty good. Also, if you looked at the real detail, it knows the ball size for the probe. That's a key piece of information. How are we probing it? All right, so once I've measured something, now I need to verify it. So here, if I pick on the OD, this right side, and then say compare that to this cylinder that we probed, you can see now at the end of the program, we get a verify statement. Verify that tolerance. It reads the tolerance. It understands what the diameter and the tolerance should be, and spits out a verify statement. So maybe do the same sort of thing on the ID, this inner bore. Say match that dimension to this probed feature. Same thing with GD&T. So if I click on that again, say here's that concentricity. I want to compare that one to that one. All right, now I'm going to get a verify statement for that. So that's where you keep going. Notice I picked on the model, but another option from drawing. So if you have a Creo drawing of this model, you can do exactly the same thing. It's strictly your preference. In this case, here's maybe the spacing from that bore to that back face. So I'll do just that. Go from here to there. And it's only letting me pick features that I have inspected. So kind of a little quality control of its own there, keeping track of all this. Okay, so there's my probing, the various faces, the various cylinders, and then the Demas commands. Verify this, verify the GTOL, put the tolerances in directly. I don't have to type those in, so there's never a typo. It uses the exact Creo model. And when you're done with it, file save. Now I have a Demas formatted text file that I can send out to my CMM. Right? Of course, this is Creo, right? And what always happens when you're just about done with your work? Well, you get that phone call. You say, hey, wait, we changed this inner bore. Instead of 10.2, it's 8 millimeters. All right, so not a big deal. The big deals really come in, what if they change just the lower tolerance, the upper tolerance, and nobody even got notified of that? Well, that's where parts start to fail. But this is Creo, so if I go in and call up the model, regenerate it, it sees that new 8 millimeter bore. If I look at my code, look at my Demas file, all the way down toward the end, you'll see, let me scroll up a little, there's my 030 instead of 050. It reads directly from the Creo model. That saves you time, saves you money. It really makes sure you're all working from the same playbook.